Right now, while you are watching this, your brain is being rewired. Not as a metaphor, the apps in your pocket were engineered by behavioral scientists to change how you think, focus, and feel. Here is exactly what the research shows is happening inside your head. In the 1930s, psychologist B.F. Skinner placed hungry animals inside a controlled testing chamber. He discovered that the most effective way to keep them pressing a lever was not to reward them every single time, but to deliver food at unpredictable intervals. Skinner called this a variable ratio reinforcement schedule. Today, this exact behavioral loop is built into your phone. Every time you pull down to refresh a feed, swipe to load a video, or watch a notification badge pop up, you pull the digital slot machine lever. Sometimes you get a supportive comment or a text, other times, nothing. According to former Google design ethicist Tristan Harris, this design is not an accident. It is engineered to capture attention. When you anticipate that potential reward, your brain releases dopamine. It is a common misconception that dopamine is the chemical of pleasure. Instead, it is the chemistry of anticipation, prompting your brain to seek more. This surge targets a reward-related brain region called the nucleus accumbens, stamping the behavior as highly important. You do not check your phone because it feels good. You check because your brain cannot resist the mystery of what might come next. At the University of California, Irvine, researcher Gloria Mark spent over 2 decades tracking how long people focus on screens in natural environments before switching tasks. In 2004, her team observed that the average attention span on a single screen lasted about 2.5 minutes. By recent measurements, that focus window shrank to roughly 47 seconds. This rapid switching exerts a heavy toll on cognitive control networks. When you jump from a work document to a social feed and back again, the transition is not instantaneous. Psychologist Sophie Leroy identified this lag as attention residue, a phenomenon where part of your cognitive capacity remains stuck on the previous activity. As these residues accumulate, the prefrontal cortex, the brain's executive control system, faces severe strain. This anterior region of the brain acts as the primary gatekeeper for goal-directed behavior, responsible for sustaining focus, suppressing impulsive distractions, and planning complex tasks. When this system is repeatedly taxed by task switching, its ability to filter out irrelevant information declines. Every sudden interruption drains its limited resources, leaving you fatigued and increasingly vulnerable to the next notification. This constant reliance on external digital tools also alters how we store information. In 2011, a study published in the journal Science, researcher Betsy Sparrow found a phenomenon known as the Google effect, or digital memory offloading. When participants believed typed information would be saved online and remain accessible later, they spent far less effort encoding those details into their long-term memory. Instead, their brains prioritized remembering the location of the information rather than the facts themselves. Rather than indexing the data, the brain indexes the directory, outsourcing its raw storage to the screen. The mental energy once used to retain information is instead spent managing the systems that hold it. This constant interaction may also leave a physical footprint inside the skull. Using structural magnetic resonance imaging scans and a technique called voxel-based morphometry, researchers have mapped the brain anatomy of individuals showing signs of problematic smartphone and internet use. These scans measure gray matter, the regions of the brain packed with the cell bodies of active neurons. Several studies, including work by researcher Lee and colleagues, have reported lower gray matter volume in areas like the prefrontal cortex and the anterior cingulate cortex. These frontal regions act as the brain's executive control center, responsible for regulating impulses, monitoring our own behavior, and sustaining focus. When gray matter in these networks is altered, self-control becomes harder. But these imaging findings come with a fundamental caveat. They are correlational. They show a clear association, not a direct cause. Researchers still face an unresolved chicken and egg question. Does excessive screen time actually alter brain tissue? Or are individuals with pre-existing structural differences simply more vulnerable to compulsive digital habits? While some clinicians, like Stanford's Anna Lemke, interpret this pattern through a pleasure-pain balance framework, where constant stimulation shifts the brain's baseline reward system, it remains a subject of ongoing scientific debate. The physical differences are real, but the precise path that creates them is still being mapped. Humans are evolutionarily wired to track social standing and relative position within a group. Feed-based environments take this basic drive and run it through a non-stop comparison machine. Every scroll presents a curated highlight reel of peers and strangers. Neuroimaging studies, including meta-analyses of social comparison tasks, show that evaluating these digital status markers activates the amygdala, a brain region involved in threat and emotional salience. For some, this constant evaluation correlates with psychological distress. Heavy use is associated with higher rates of anxiety and depression, particularly in adolescence. Social psychologist Jonathan Haidt argues this dynamic acts as a primary driver of a youth mental health crisis. But the scientific community remains divided. Researchers like Candace Odgers point out that these population-level correlations are actually small and do not establish direct cause and effect, reminding us that digital habits are just one variable in a young person's life. As night falls, the physical toll of these habits shifts directly into your biology. The screen in your hands emits a peak light wavelength of 460 nanometers. This specific blue light mimics daylight, fooling your brain and suppressing the release of melatonin, the hormone that signals sleep. The result is delayed sleep onset. When you finally drift off, the quality is compromised. Evening screen exposure reduces slow-wave sleep, the brain's repair and file-away stage, by roughly 15%, weakening memory consolidation. The damage carries into the next day. Sleep deprivation can double your amygdala's reactivity to negative experiences, leaving you emotionally volatile. By fracturing your rest, late-night scrolling directly fuels daytime stress. The brain is an adaptable, changing organ. It possesses neuroplasticity, the biological ability to reorganize itself by forming new neural connections in response to repeated behavior. The same adaptability that allowed digital platforms to shape your habits also allows your brain to recover when those habits change. When you reduce constant online stimulation, your dopamine baseline begins to normalize, lowering that restless, compulsive urge to check your phone. While popular culture promotes extreme trends like dopamine fasting as a sudden cure, science favors a more modest reality. There is no instant reset button. True recovery happens through gradual, sustained behavioral shifts. By making small, intentional adjustments to your daily routine, you can quiet the constant noise and allow your attention networks to rebuild. Subscribe to our channel to support more evidence-based science documentaries. Instead of relying on sheer willpower, behavioral researchers advocate for changing your immediate environment. A 2022 randomized controlled trial showed that batching notifications into 3 daily periods reduces stress and cuts phone checks by 30%. Turning off non-essential alerts breaks the unpredictable reward loop entirely. To strip away the biological pull of bright social feeds, switch your screen to grayscale. Trials show the simple color removal reduces daily unlocks by 20%. Moving devices out of the bedroom entirely can claw back 38 minutes of deep sleep per night. These environmental defaults require zero daily effort to maintain. The ultimate goal is not to abandon technology, but to rebuild a baseline of intentional use. Our brains remain remarkably plastic, capable of adapting to the deliberate limits we set. The future of your attention is not decided by an algorithm. It is shaped by your next offline choice. Subscribe for more science-backed insights into our changing minds.